Okay, hi guys. I couldn't find a video on the outcome that we were looking at this week, so I'm making my own video. So we're going to start off by reviewing the work that you guys were doing last week, which was classifying of triangles, both by side lengths and by angle size. So to start off, right, we know that if you're classifying by side length, okay, there are three different ways that you can classify a triangle by its sides. So the first is equilateral, and we know that that's when all three sides are the same, and that's easy to remember because it actually literally says equal in the word. The second way is an isosceles triangle, and that's when there are two sides the same and one that are different. Okay, so you'll have something that looks like that, right? These are called hash marks, and these hash marks mean if there's one through each one, that means those are the same, and that indicates that that is different. And then, of course, there's the one where they're all different. Okay, so it's 1, 1, 1, and that's called a scalene. And of course, we know that that's when all three side lengths are different. And what's kind of neat about this as well is even though we talk about side lengths, it also actually applies to the angles as well. In an equilateral triangle, not only are the three sides equal, but the three angles inside are equal. In an equilateral triangle, all three angles, equal up to 60. In an isosceles triangle, it's the same thing. So it has two side lengths the same, but it also has two side lengths of equal length, but it also has two angles of equal size. So let's just pretend that this one maybe has, like let's say this one's 80, and then this one would be 50, and this one would be 50. Again, I'm obviously not doing anything to scale. And in a scalene, all three side lengths are not the same, so they are unequal, and it has all three different angle length or sizes as well. So again, equilateral means that all three side lengths are the same, and also that all three angles are the same. Isosceles means that two sides are the same, one is different, and of course the same goes with their angles. One angle is different and two angles are the same. And scalene is all three angles are different and all three sides are different and all three angles are different. Okay, so the first way to classify is by side length. Of course, we also looked at angles a little bit, but the other one is by angle size. Okay. And this one can get a little bit confusing. So an acute angle, triangle, is when all three angles all three angles in a triangle are acute. So if it only has acute angles in it, then we call it an acute triangle. But it's important for you to note that all triangles will have acute angles in them. In fact, all triangles will actually have two acute angles in them. Okay, so every triangle is going to have acute angles, and all triangles will actually have two acute angles. You only call it an acute triangle, though, if all three are acute. So then there's a right, okay, something like that. It has a right triangle or a right angle in it. So if it has a right angle, then we call that a right triangle. Remember, it's not all three of their angles are right. It can't actually happen, and we're going to learn about that today. But if it has a right angle, then it is in fact a right triangle. These other two angles in this triangle are in fact acute. So remember, it has to have all three for it to be considered acute. If it has a right angle, we call it a right triangle. And then there's the obtuse. There we go. Right there, that's an obtuse angle. So if it has an obtuse angle in it, we call it an obtuse triangle. And then typically, when you're talking about triangles and you're classifying, you actually put both classifications together. So I'll erase this. So for an equilateral triangle, okay, all equilateral triangles are acute because we know that it has to have the same amount of angle size inside, and each angle is 60 degrees. So always an equilateral triangle is acute. And then the other two types of triangles can be obtuse or they can be right, depending if they have, or acute. So I can have, for example, if I did this, okay, and then this has a right angle in it, and this has two side lengths that are the same and one side length that is different. So this would be a right isosceles. Okay, so I'm looking at both classifications. I'm looking at its sides, and then I'm also looking at its angles. And then maybe I could do something like this. So maybe I would do, whoa, that looked kind of weird, but so we'll say that all three of these are different. So I have all three different angle sizes different. And so this would be, and then obviously, or pardon me, all three side lengths are different. And then I also have an obtuse angle in it. So let's say that I would call this an obtuse scalene. But it's really important for you guys to know that you can have a right scalene, or you can have an acute scalene. You can actually have a scalene that has all three different angles or all three different sizes of side lengths, but in fact it has all acute angles in it. Okay. So what I'm going to teach you today is actually super easy but super cool. So this is one of those neat things about the world, I think. Like, it's one of those things that it's just like, this is like a fact about the world, and it happens every single time. Somebody discovered it, I don't know who, but like way back probably in Greek times or something. It's like some kind of like super cool geometry thing. So I'm going to go and give you an example of back to the an equilateral triangle. So we know an equilateral triangle has three side lengths the same, and because we know that all equilateral triangles have the same angle sizes, that they are 60, 60, and 60. And I'm sure you've seen that when we were actually reviewing, and I had a couple of if you did any of the supplementary work. And that's because the interior angles of a triangle, so the angles in any triangle, but the inside ones, right? Like not looking at the outside, always, always, always add up to 180 degrees. So 60 plus 60 plus 60 equals 180. And this works on every single triangle. Doesn't matter what kind it is. So let's say I've got this. Whoa. So I've drawn myself a scalene triangle here. I'm going to say, well, let's do a little bit of estimation here. I'm going to just take this box that I've got. I know it's an obtuse. It's not hugely obtuse. Let's say this is 100 degrees. Okay, that's a 100-degree angle. Now these two are going to be different because it's a scalene triangle, and we know that scalene. And I'm going to just say, well, this one looks pretty small. So let's say this one is, this one's actually smaller. Let's just estimate and say that this one is a 40-degree angle. Okay, no, it can't be. Let's say that this one is a 30-degree angle, 50. There we go. Let's say that this one is a 50-degree angle. Now I know that all three angles have to equal to 180. It's just a fact. Like this is the outcome. All three angles in a triangle have to equal to 180. So I would take angle 1 plus angle 2 plus unknown angle. 100 plus 50 is 150 plus we don't know equals 180. Well, that's pretty easy to figure out. 150 plus 30 is equal to 180, and this triangle then would be worth 80 or 30 degrees. Now, if I was really going to do this and I was going to have triangles and draw them, and I could do this with I could literally take this with my protractor and measure this out. But trust me, like I'm not doing it, I'm kind of going the quick way, but this is how this works. No matter the type of angle or no matter the type of triangle, every single triangle, the three angles together will equal 180 degrees. So A plus B plus C equals 180 degrees, no matter what. So if I did this one, okay, I know this is right, so I know that that's 90 degrees, plus, and let's say I had something that looked like this. So this is telling me that this is a right isosceles triangle. So if this is 90, then I don't even need any more information than this, because I know that these two angles have to be the same, and I know that these two angles plus 90 have to equal 180 degrees. So what two numbers equal what's left, which would be 90? Well, 45. So 45 degrees, 45 degrees. So 45 plus 45 plus 90 is 180, and those are the angles in that triangle. So a lot of the practice that I'm giving you this week is find the missing angle, we call it, okay? So you're given the triangle, okay? You're given maybe one of the angles, or maybe it looks more like this, okay? Maybe I'm giving you two of the angles. In this case, I might say, well, this is 100 and this is 50, and then you have to figure out what the other angle is. So you're knowing that angle A plus B plus C. So adding up the three different angles in a triangle will always equal 180 degrees. It's actually really cool. Okay, and this is where I'm sneaking in the second outcome, just because we need to move a little faster. So last year in grade 5, I'm assuming you guys learned about quadrilaterals. So a quadrilateral is just a really fancy way of saying a four-sided polygon. All right, so a rectangle is a quadrilateral, a square is a quadrilateral. There's different types of quadrilaterals, right? Like that's a trapezoid. Trapezoid is your quadrilateral. You've got like ones that look like diamonds, right? Which are kind of like squares, like on its side. Those are called rhombuses. Those are called quadrilaterals. But we're going to look at, we're going to pretend it's a perfectly drawn rectangle. Now, what do we know about the corner of a rectangle or a square? Well, we know that those four angles are right angles, which makes these 90 degrees. 90, 90, 90, 90. Well, what's 90 times 4? 360. So, just like in a triangle, where the three angles will always add up to 180 degrees, in a quadrilateral, the four angles, will always add up to 360. And it doesn't matter whether it's a rectangle, or it's a square, or it's something that looks like this, right? A trapezoid. These four angles will still always add up to 360 degrees. A rhombus. These four angles will always still add up to 360 degrees. It's just like geometry magic. It's pretty cool. Okay, so this is the outcome that we're learning this week, or outcomes, because I'm kind of sneaking in the quadrilateral one quickly. So you have to be able to demonstrate an understanding of how the three triangle or angles in a triangle always equal 180 degrees. And then you have to show me that, you have to be able to show me that the four angles in a quadrilateral, any quadrilateral, will always equal 100 or 360 degrees. Okay.